wave functions. Okay, psi A 0, psi B 0. And then what I told you, that psi 0 will be another function with the same energy eigenvalue E0. And therefore what we had was H0 psi 0, this was equal to E0 psi 0. Okay, now then we switched on the perturbation and we wrote the time evolution equation as H psi is equal to E psi, and obtained two equations. One was alpha WAA plus beta WAB. This is equal to alpha E1, and then alpha WBA plus beta WBB is equal to beta E1, where what are these W's? These W's are the matrix element of the HI, the perturbed Hamiltonian, with respect to the unperturbed wave function psi A 0 and psi B 0. Therefore, if you recall, W's are the matrix elements. W's are the matrix elements W's are the matrix elements of the perturbed Hamiltonian with respect to the unperturbed wave function psi A 0 and psi B 0. Recall, our WAB was psi A 0 HI psi B 0, and WBA was the conjugate of WAB. Now with this we obtained a quadratic equation in E1, and the result was E plus minus 1. This was equal to half WAA plus WBB plus minus WAA minus WBB whole square plus 4 WAB whole square. This is what I told you, that this is the fundamental result of degenerate perturbation theory. Okay, this is the fundamental result of degenerate perturbation theory. Of degenerate perturbation theory. Okay. Now we took the different possible cases. One was when alpha equal to 1 and beta equal to 0, and other was alpha equal to 0 and beta equal to 1. From here we know that mod alpha square plus mod beta square, this should be equal to 1. Now if I am taking alpha equal to 0, then for sure beta should be 1, or alpha, if beta is 0, then alpha must be equal to 1. Therefore, if you look back at your equation, then for the case when alpha is 1 and beta is 0, the energy that you are getting would be, just you can verify, this will be WAA psi A0 HI psi B0. And similarly for the other case, the energy would be -1 WBP, and that will be equal to psi B0 HI psi B0. Therefore, the important point is, if you notice why these two results are important, because if you have only psi A0 or only psi B0, then this is the same result what you had obtained for non-degenerate perturbation theory, first order correction to the energy. Therefore, these, when you consider alpha equal to 1, beta is 0, or alpha is 0, beta is equal to 1, then you are getting a result which exactly matches with your result when you consider non-degenerate perturbation theory. In the case of non-degenerate perturbation theory, the result was psi 0 HI psi 0. This was the first order correction to the energy. The same results you are obtaining it here. Now the expression which I wrote with the WAA and WAB, this you can also write in the matrix form as WAA, WAB, WBA, WBB, alpha beta is equal to E1 alpha beta. And therefore, E1, what are these E1? As you can notice, these E1s are nothing but the eigenvalues of the W matrix. Therefore, E1 is nothing but the eigenvalue of the W matrix. Now, we have considered only two-fold degeneracy, psi A0 and psi B0. In general, what I had told you, that you can have many-fold degeneracy, and in that case, what will happen? Instead of writing on separately the equations, just you can write the matrix as WA for threefold, for example, WAC, WBA, WBB, WBC, WCA, WCB, WCC, alpha, beta, gamma, that will be equal to E1 alpha, beta, gamma. Or n-fold degeneracy, similarly you have to consider n-column vector to achieve n-fold degeneracy. This is how we work in the case of degenerate perturbation theory. And then you can take one example, and I am taking the example, since I am following Griffith, I am taking the example 6.2 on page number 262 of Griffith books, that consider three-dimensional. What?
सर रह गया पीछे अभी उतारने से.
I am sorry for that. I am writing it here. WAA, WAB, WAC, WBA, WBB, WBC, WCA, WCB, WCC, alpha, beta, gamma, E1, alpha, beta, gamma. And then you can generalize it to n-fold degeneracy. और भी कुछ रहा था, मैं वापस सोचूं.
सर ये लिखना था बस.
Now, what I am doing a simple example. of a cubical well. Okay, three-dimensional cubical well, because this will have threefold degeneracy. Okay, therefore consider the three-dimensional infinite cubical well Bxyz is 0. Inside the well, the particle is free to move. Okay, this is a three-dimensional well. As you know, the time-independent solution to this problem, for one-dimensional, this was 2 by L sine n pi by L into x. Now in three-dimensional, this will be how much? Sine nx, ny, nz, xyz. You will count it 3 times. That means square root 2 by L 3 times. Sine n pi by L x, sine n pi by L y, and sine n pi by L z. And what was the energy in a one-dimensional infinite square well? This was n square pi square h cross square by twice ml square. This was the energy in one-dimensional infinite square well. In three-dimensional infinite square well, this would be equal to Enx, Eny, and Enz, the unperturbed energy. This will be pi square h cross square by twice ml square. And instead of n square, and we will write it as nx square plus ny square plus nz square. Nx square plus ny square plus nz square. Therefore, we will have now if I ask you the question, what will be the ground state? Then here n was equal to 1, the ground state. Here all nx is equal to ny equal to nz. This will be equal to 1. Then that means the ground state energy, or I should write the ground state unperturbed energy is 0, unperturbed. This will be equal to 1 plus 1 plus 1, that is 3 pi square h cross square by twice ml square. This will be the ground state energy for a three-dimensional infinite cubical well. Infinite cubical well, the ground state energy is this much. Now if should I change the slide?
Yes, sir.
Now, the first excited state, here there is a two-fold degeneracy, because first excited state will correspond to nx is equal to 2, ny is equal to 1, nz is equal to 1, or nx is equal to 1, ny is equal to 2, nz is equal to 1, or nx is equal to 1, ny is equal to 1, and nz is equal to 2. And this will give us a wave function psi 2 1 1. This will give us 1 2 1, and this will give us 1 1 2. This is what we call it as threefold degeneracy. Why we call it as threefold degeneracy? This is because the expression which I wrote, nx, ny, nz, zeroth order perturbation, pi square h cross square by twice ml square, nx square plus ny square plus nz square. For any of these three combinations, what will be the energy eigenvalue? The energy eigenvalue would be the same. The energy eigenvalue would be the same. 2 square plus 1 square plus 1 square. That means 6 upon 2, and that will give me 3 pi square h cross square by ml square. Is it fine? Now,
Yes, sir.
now actually the game starts, because till now we have considered that we have the unperturbed Hamiltonian and we have the pure wave functions. But what happens when I switch on the perturbation and say that perturbation is V naught in the region for x lying between 0 and L by 2 and y lying between 0 and L by 2, otherwise it is 0. Otherwise it is 0. Therefore, Hi is V naught for x lying between 0 and L by 2 and y lying between 0 and L by 2. Otherwise, this is equal to 0. Now we have to obtain first order correction to the energy, and as you can see that we have only applied the perturbation in the region Z, in the x and y region, and even up to L by 2 only. That means the perturbation is applied only in 1/4 of the box. We are applying perturbation in only 1/4 of the box. And then what we want to do, we want to first calculate the first order correction to the energy. And what will be the first order correction to the energy? This will be psi 1 1 Hi psi 1 1, because still we have the ground state wave function, and then for the excited state we will have a separate equation where 1 2 1 2 1 1 and 1 1 2 will come into play. But when we are switching on the perturbation, first there will be correction to the ground state energy, and then we will consider the excited state. Therefore, if you notice, what is this ground state wave function? This is psi 1 1 star Hi psi 1 1. This is a 3-dimensional infinite cubical well. Therefore, we have dx, dy as well as dz. And what is the wave function? Psi 1 1, as you can recall, just I wrote previously for the ground state. This was square root 2 by L sine nx is 1, therefore this is pi by L into x, and y is 1 pi by L into y, and nz is 1. This was our ground state wave function corresponding to nx, ny and nz. And as you can see, we are applying only the perturbation in region of x and y, leaving
So root 2 by L to the power 2 by 3.
cube. Okay? Root 2 by L cube. And that is the same as okay, is it fine? Because we have to count root 2 by L 3 times. Therefore,
Yes, sir.
this will be root 2 by L to the power 3. Now you see, I will write here this expression and I will write here. This means that again we will take root 2 by L to the power 3, and that means this will simply become as 2 by L whole cube. Therefore, we have 2 by L whole cube. The perturbation is only V naught, and it is applied in the region, in the X region, in the interval 0 to L by 2, sine square pi by L into X dx, then 0 to L by 2, sine square pi by L into Y dy, and then in the third region, there is no perturbation, therefore this will be 0 to L sine square pi by L z. Okay, see, we are applying perturbation only to the quarter of this cubical well. Remember the result when I considered in one of the example that we are raising the complete well by a height V naught, then the first order correction was just simply V naught. Here if it is in the quarter of the well, what should be the answer? This should be V naught by 4. Now when you will solve this, the answer that you are getting would be simply V naught by 4. Okay? Therefore, the first order correction to the energy when you have raised the well by L by 2 in region of X and Y, the overall you have only raised quarter of the well. Therefore, the change in energy that would turn out to be E0 plus 1 by 4 V naught. E0 plus 1 by 4 V naught. Okay, this will be our result. Now, actually, we have to talk about what will happen when we will consider the first excited state. Okay, that means psi 1 2 1, psi 2 1 1, and psi 1 1 2. Now, since we are considering threefold degeneracy, therefore the expression that we have to bother about is WAA, WAB, WAC, WBA, WBB, WBC, WCA, WCB, WCC, alpha, beta, gamma, E1, alpha, beta, gamma. Now, what is WAA? This is, tell me. What was our WAA to start with?
Psi A H I.
Psi, which psi?
Psi naught A.
Psi naught, unperturbed. Mind it, it should be unperturbed. That means, what will be W? This will be psi, because this is unperturbed. Okay, psi 1 1. Okay, then HI. Okay, and this, similarly this will be psi BB and psi CC. Now tell me what will be this result for all of them. Anybody?
So V naught by 4.
All of them will be V naught by 4. The same integral that we have worked out. Okay, we have to repeat the same here. CHI is the perturbation which will work in the region 0 to L by 2 in X and 0 to L by 2 in Y. Okay. Now that means these three are quite easy. The other thing that we know that WAB is the conjugate of WBA. Similarly, WAC is the conjugate of WCA and WBC is the conjugate of WCB. Okay. That means instead of 6 remaining one, how many we are supposed to solve? Only
3, sir.
3. Okay, only 3. Okay, now tell me what will be WAB? This will be just I am writing, you can verify 2 by L cube V naught 0 to L by 2 sine square pi by L into X dx, and then 0 to L by 2 sine pi by A into pi by L into Y sine here 1 to 1, and that means pi 2 pi by L into Y dy 1 to 1. Then the Z part 0 to L sine 2 pi by L into Z times sine pi by L into Z. This will be WAB. This will be WAB. Okay?
सर ये वाली बात एक बार फिर से बताइए प्लीज. ये वाला इंटीग्रल हम कैसे लिखते हैं?
कैसे लिख रहे हैं? ठीक है. See, what is my WAB? Tell me. What is my WAB? We go back to our basics. That was psi
A0 HI
psi
B0.
Okay. This was the basic definition of WAB, and then WBA was psi B0 HI psi A0, and that is what I am telling you, that WAB is WBA star. Is it clear?
Yes, sir.
Okay. Now we have to consider what in this connection where when we are considering X region, that will be psi. Tell me what will happen. Psi anybody? What will be the wave function in this case? There are three regions, and the wave function is psi nx x by L times psi ny y by L times sine nz z by L. We are talking about raising it in the region 0 to L by 2. Okay, then that means what will be our wave function? What will be WAB? Tell me, what will be WAB when I am considering this? This will be psi A0, HI, psi B0. What will be in my case psi A0 and psi B0? See here, there will be term with X, with Y, and with Z. Okay, you have X here, Y, and Z. What this will correspond to when you will consider WAB? This will be psi 111 HI psi 111 psi 111 psi 121 for Y. This will be for Y. This will be for X, and psi 111 psi 112. You look at the matrix element, you will come across these three terms. And this is what I have written here, that for this part, simply the wave function is square root 2 by L sine pi by L into X. This will have both sine pi by L into Y and sine 2 pi by L into Y, and this will be for sine pi by L into Z and sine 2 pi by L into Z. This is what you will get. This will be for the region 0 to L, this will be for the region 0 to L by 2, and this will be for the region 0 to L by 2. Okay, and then if you evaluate this WAB, then this will turn out to be how much? How much would be this part? Anybody without doing anything?
Zero.
0. And therefore the complete term would be equal to 0. Okay, this is something like sine A sine B, or sine theta sine A theta sine 2A theta d theta. You work out this, okay, in the interval 0 to L. This will turn out to be 0. Now if this is not clear to you, talk about what will be WBC keeping the same analogy. WBC keeping the same analogy. Now when we will talk about WBC, then this part will have psi 11. This part will have psi 1, psi 11, psi 121. And this part will have psi 211, psi 11. Or, okay, this is what we will write. Just let me tell you one thing. This will be psi 11, psi 11. Okay, this is WAA. And then when I am trying to get WBC, what will be this? This will be again 2 by L whole cube V naught 0 to L by 2 sine pi by a L into x sine 2 pi by L into x dx, 0 to L by 2 sine 2 pi by, or I should write sine pi by L into y, sine 2 pi by L into y dy, and the third will be 0 to L sine square pi by L z. And this will turn out to be a non-zero quantity. While WAA, WBB and WCC turn out to be V0 by 4, you may see that WAC like WAB will also turn out to be equal to 0. And if WAC is 0, then that would imply WCA will also be 0 because one is conjugate of other. If WAB is 0, that would imply that WBA will also be 0. And therefore, WBC is non-zero, that means WCB will also be non-zero. Say I am not evaluating this, I am calling this as some constant, say delta. So therefore, what will be WCB? That will also be delta, okay, a constant. Therefore, the matrix element that you will get will have a V0 by 4 because WA, WBB and WCC, they are 1, and WBC and CA are non-zero. Therefore, WAB is 0, WAC is 0, WCA is 0, C is my W is V0 by 4, 1, 1, 1, 0, 0, 0, 0, and I had obtained a result delta. When I am taking common V0 by 4, that will be some delta prime. Therefore, I can write here some delta prime and delta prime. And you can notice that I am getting a matrix, and if I have this matrix, then using characteristic equation, the characteristic equation for this W, okay, we can work out for the eigenvalues of this and obtain the result, and that result would be something like, you may check, something like E1 is equal to E1 0, first order correction to the unperturbed energy, plus lambda V0 by 4, E1 0 plus lambda 1 plus kappa V0 by 4, and E1 0 plus lambda 1 minus kappa V0 by 4. Where what is kappa? Kappa is a constant factor, 8 by 3 pi whole square you will find. This is approximately 0.72. And what is lambda?
Sir, eigenvalues for W.
Eigenvalues for W. Okay, this will be the eigenvalues for W, and these will turn out to be W1 as 1, W2 as 1.72, and W3 as 0.28. Try to obtain it. If you are able to obtain it, that would be fine. Otherwise, I will send you the complete solution. Okay. Now, this was an example, but the important point is that when we talk about degenerate perturbation theory, therefore we can have n set of unperturbed eigenfunctions, and then when we switch off the perturbation, we find that the energy gets changed, and this change in energy is not the same for each case. Okay. The next 10 minutes which I am going to talk about is a very important concept, and please concentrate on this to understand what will be the next 2-3 lectures of our discussion. See, I am going to talk about the application of perturbation theory to the realistic problems. Okay, up to this point, everything was theoretical. Now, we are going to apply perturbation theory to realistic problem. And the first problem that is there in your syllabus is the hydrogen atom. Now, what do you know about hydrogen atom? Oh, sorry. That there is an electron revolving around the nucleus, and in the case of hydrogen atom, there is only one proton, and the centripetal force is provided by the Coulombic interaction energy, mv square by r. This is equal to 1 by 4 pi epsilon naught E square by R square. And Bohr's important contribution was that the electron which is revolving around the orbit, their angular momentum are quantized, and the angular momentum is given by nh cross. This was the quantization concept which led to the quantization of the orbit, and later, finally, to the quantization of the energy. Therefore, first the concept was that the angular momentum of the electron is quantized, and that led to the quantization of the orbit and the quantization of the energy. And as you know, this value is, if I remember correctly, minus me4 by 8n square h square epsilon naught square. And this in general in all the books is written as minus 13.6 electron volt by n square, where 13.6 electron volt is known as Rydberg constant. Okay, this is the energy of hydrogen atom we talk about, and then we say that in the ground state energy is minus 13.6 electron. Now this is purely based on the concept that the Hamiltonian, I am writing now unperturbed Hamiltonian, this is p square by twice m plus Vr. Instead of Vr, this will be minus E square by 4 pi epsilon naught R. What is this Mr? What is this Mr?
So reduce mass of proton electrons.
Why we consider reduced mass?
Sir, to make it a one body problem.
To make it a one. How we did that? How we did that? Mehak, Rayan, Saddam, anyone?
सर प्रोटॉन को रेस्ट पे मान के
No. What we did, we started with, in general, the kinetic energy of electron plus the kinetic energy of the proton plus the interaction energy. That was minus E square by 4 pi epsilon naught R. Kinetic energy of electron plus the kinetic energy of the proton plus the interaction energy. This was the equation. Okay? This is the basic equation, fundamental equation, where this psi is depending upon a location of electron in space as well as the location of proton in space. Okay? It depends upon the location of electron as well as location of proton in space. Okay? But what we do, instead of solving this, we introduce, if you recall from your B.Sc final days, relative coordinate. जिन लोगों ने नहीं पढ़ा है और वो दोबारा इसको देख लेंगे B.Sc की किताब से. And center of mass coordinate. What was the relative coordinate? Relative coordinate was RE is equal to RE minus RP or RP minus RE, whatever you call. And what was center of mass coordinate? This we write it as psi R MERE plus MPRP upon
RE plus RP स्क्वायर नहीं
What is the center of mass coordinate? Anybody?
So ME plus MEP plus
ME plus
MP.
anybody else?
M1 R1 plus M2 R2 divided by M1 plus M2.
M1 R1 is MERE plus MPRP upon MP plus. Okay? है ना, R1 R2 से हमारी रिश्तेदारी नहीं है. If I am defining the position coordinates by RE and RP, then this will be MERE plus MPRP upon ME plus R. Then what happens when we introduce relative coordinate and center of mass coordinate? And a reduced mass of the system, which reduced mass is defined as 1 by mu ME plus MP, which is equal to ME MP by ME plus MP, and that is for electron proton system. Since this is 1836 times smaller, we put it into the dustbin, and this mu is equal to ME. This mu is equal to ME, simply ME. Therefore, in all the books, you will find hydrogen atom, for the hydrogen atom problem, the Hamiltonian is written only in terms of the mass of the electron. But it is not true. It should be in terms of the reduced mass And reduced mass in this case turns out to be the mass of the electron. But had it been an electron-positron system where electron and positron, they have got the same mass, then this will be me square upon twice me. That means me by 2. Therefore, this depends upon what masses you are taking into account. Okay. Now, when you introduce the relative coordinate and center of mass coordinate, then what happens? You get two equations. One equation is completely in capital R, and another equation that is completely in small. The equation that you get completely in capital R, because the potential only depends upon the relative distance between electron and proton, because the Coulombic potential is 1 by 4 pi epsilon naught E square by R, where R is the relative distance, magnitude of the relative distance between electron and proton. This capital R has, from here you will get an equation twice m, the sum of the masses of electron and proton, psi r is equal to E psi r, total energy psi. This equation will be without any potential. And the other equation you will get in terms of reduced mass. Will be this, which will contain the interaction potential. And this is the equation for a free particle. And since here the particle is bound, therefore we don't talk about this free particle equation, because its solution, yes?
So why this the phi capital R equation doesn't contain the potential term?
Because we are talking about Coulomb interaction term, and the Coulomb interaction term is only depending upon the relative distance between the two particles.
So it
only depends upon
cannot
R.
be considered.
RE minus RP.
So sir, it cannot be considered from this cap.
No, from when you will separate it into the equation which has everything in small r, an equation which has complete everything in capital R, what you will come across that for the potential which is only depending upon the interparticle distance, there this equation which is in capital R will be equal to, it will not contain any potential, and this will be simply an equation which will be for the, when there is no potential, that means the particle which is having this fictitious mass capital M.
Sir, for example, we have in the binary star system, we reduce the distance to the center of mass, and then we take the distance to the two stars as R1 and R2, and there we consider the energy. So in that term, we cannot consider the energy here if we are talking about the relative distance between them.
See, you are getting confused. See what I am telling you. This is an electron. This is a proton. And what is this relative distance? Is only RE minus RP or RP minus RP. Because what is the Coulomb interaction energy? In principle, you may wish, you may write it as this. But the important point is there is no term on the right hand side which has capital R. It is only the absolute value of the relative distance between the two particles. Whenever you will consider that, okay, there is some change, and this is what I had told you in one of the class, that in general, when we start with, we write it as vector R in Schrodinger equation. Then I told you that in almost 90% of the problems that we will discuss, this V in general should be function of relative distance, the zenith angle dependence, and the azimuthal angle dependence. But for example, I told you the example of quadrupole moment of the nucleus, which has zenith and theta dependence, because you talk about rotation of the nucleus, you talk about an angle theta, then you cannot write simply as VR. You have to consider V, relative distance, and theta, the zenith angle difference. Then you cannot apply this formalism over here. Therefore, in general, if I talk about potentials which are depending upon relative distance as well as center of mass distance, then we cannot apply method of separation of variables. You can only apply method of separation of variables when your potential is depending only upon one of the coordinates. If they will depend on both of the coordinates, like you are telling R and R, then you cannot apply method of separation of variables, because you cannot write V in terms of R and S capital R. Then this formalism won't be applicable. Is it clear?
No, sir. Still not clear.
Still not clear. See what, let me just go to another slide. What I am telling you, that...
So actually, I am unable to frame my question. So I will write it to the WhatsApp group.
No, don't worry about that. See what I am telling you, that psi is a function of x, y, z, capital X, capital Y, and capital Z. Do you agree with this? That for two body system which are localized in space, your psi will function of x, y, z for one particle, and capital X, capital Y, and capital Z for another particle.
Yes, sir.
Okay. Then what I am telling you, that if I am writing Schrodinger equation, okay, let me first write this. At psi is equal to IH cross delta psi XYZ XYZ. First of all, the important point, if there is time dependence, like in radioactivity phenomena, like in laser beam, like other places where there is a time dependence, where you are talking about a stimulated emission, where you talk about absorption, where you talk about a finite lifetime in a given state, then, my dear, you won't be able to get rid of this time part. And that is why, in general, when we write this expression, first of all, what we do, we say that my psi, which is in general function of time, for time independent problem, we can write it into two parts, the time component and the space component. And what is the solution corresponding to time component? That is minus IET by H cross. And then I had told you, in the all expectation values, this quantity will come with a complex conjugate and will not appear in your final result. Is it clear?
Yes, sir.
Then we come to this problem. That okay, that means if we are able to see, first of all, if we are able to separate it into time component and space component, then only we will be able to obtain an expression which we call by the name time independent Schrodinger equation. Time independent Schrodinger equation, which you write it in general. Is it clear? Now, instead of x, y, z, I told you that we can write Is it all right? Now my point,
Yes, sir.
my point is that if VR is depending upon zenith angle dependence as well as azimuthal dependence, and the real example which I am giving you is that if I am talking about a radioactive nucleus, if I am talking about a stimulated emission, if I am talking about excited state and which are going to de-excite, or we are talking about unstable states, then what is the basic problem? Then we are not able to separate the potential into, first of all, we will be unable to set the potential into only the space part. It will also depend upon time. Similarly here, when we talk about the quadrupole moment of the nucleus, or where there is no spherical symmetry, where there is no spherical symmetry means the potential depends only upon the relative distance between the particles. Like I have written so many times in the class, 1 by r or e to the power minus mr by r, or e to the power minus mu r square by r square, or something like that. These are all the examples where the potential is only depending upon the relative distance, or potential is only depending upon magnitude of r. If the potential depends upon theta or phi, then we cannot proceed from here by separating psi r into something like a quantity generally we write in the class rr, theta theta, and phi phi. And this theta phi generally we write it as y theta phi. When we separate it into rr and y theta, see, I am only talking about a one body problem moving in a potential. One body problem moving in a potential. And the potential, what I am telling you, is depending upon r, theta, and phi. If the potential is depending upon r, theta, and phi, then remember, you cannot use the method of separation of variables. Why? Because when we talk about v as a function of r only, then we have only an equation which is in r and contains Vr, while theta and phi, which is function of zenith angle, and phi, which is function of azimuthal angle. If you remember in your B.Sc final days, this equation was d square phi by d phi square plus m square phi. This is equal to 0. And this was giving you e to the some normalization constant, e to the power plus minus im phi. This you cannot won't be able to obtain if the potential is depending upon theta or phi. Is it clear?
Yes, sir.
Similarly, I am arguing for two-body problem. That two-body problem can be reduced to one-body problem only when the potential depends upon the relative distance between the particles. Otherwise,
sir.
you won't be able to do that.
Sir, that thing is clear to me, but sir, I'm asking that this potential is depending upon the relative distance between the particles, and we are taking center
That
of
means
mass.
small.
This is small, and we are taking center of mass coordinates. So in center of mass coordinates, if we take the distance from that center of mass to one particle as r1 and to the other particle as r2.
That is why when again, if that means you have again r1 and r2 in mind. Once we have introduced capital R and small r, we will forget about r1 and r2. It is something like when you introduce x, y, z, you forget about r theta phi. Or similarly,
Yes,
from r theta phi, you go to cylindrical coordinates, you forget about what was your x, y, z. Similarly here, when we have r1 and r2, we were talking about a specific position of electron and proton. But when we introduce reduced mass and center of mass, now practically speaking, whether you have a reduced mass system,
no, sir.
that means you are talking about a fictitious particle which has got a reduced mass mu. Is it not?
Yes, sir.
And then the same is true for capital M, which is depending only upon capital R, center of mass coordinate. And with capital R, it has no potential dependence. And that is why that equation is independent of potential, and that is why the solution will be solution for a free particle. And then we argue that solution for a free particle we are not concerned with, because electron proton is a bound system, and therefore we should bother about the interaction part, the equation that is associated with VR. Okay, and that is why I wrote minus h square by twice m del squared psi small r plus VR psi r. Let me stop here. Again, I will come back to this tomorrow. Or even if you will have confusion tomorrow, I will repeat it. I want to convince you that what is my plan. Okay?
Yes, sir.
Okay, let's